Hello, my name is Brian Flint. I'm doing this talk today because the James Webb telescope has recently been launched. I mean, the date today is the 10th of February 2022, and the James Webb telescope is now being commissioned or aligned, and this process will take a few months. This is an incredible achievement for this telescope to be launched. This talk is also a continuation of some previous talks which I've done. I did these in 2019. One of them is the Big Bang theory and how they got it wrong. The other one is everything in the universe originated from the inside of a black hole. Now, I suppose the talk I'm doing now is there is no such thing as a proto-galaxy. Very shortly, the James Webb telescope will be capturing images of far distant galaxies. The light from these galaxies would have travelled for 10 billion years, billion being a 1,000 million, and they're expecting that these galaxies will be different in formation to what you would see on the galaxies at the moment, which typically say 1 billion years ago. They're expecting the spiral galaxies, for example, not to really exist. The galaxy will be a sort of a swirl of gas and very little structure as seen in a spiral galaxy. A spiral galaxy has got these arms radiating out from the central portion filled with millions or billions of stars. The early results from the images they get in the infrared spectrum of these stars, or galaxies rather, from 10 billion years ago will cause a lot of confusion, bewilderment, because all they seem to find are spiral galaxies and elliptical galaxies, the normal sort of galaxies which have been observed for years. Now, the reason they can't see any primeval galaxies is because the basic premise of how galaxies are formed, I believe, is wrong. My hypothesis is that galaxies are formed in a completely different way. I'll explain. My definition of a galaxy is a collection of black holes. There are a number of black holes of various sizes, all orbiting each other, and this constitutes a galaxy. There may be lots of stars surrounding these black holes, or there may not. Now, why do I think this? Well, these black holes are orbiting each other, and the smaller ones are neutron stars, the remnants of stars which have ended their life, and there are many of them, maybe 1 million or more of them. They're all circulating around each other in a sort of orbit amongst some larger black holes. I mean, I consider a neutron star really to be a black hole, just a very small one. As these black holes orbit each other, they will merge and create bigger black holes. These, these bigger black holes will invariably have a spin. The spin is very fast. I mean, it could be 1 second a revolution. I'll give an illustration of how a black hole can acquire a large amount of spin. So, this fist represents one black hole, and this is another. They're orbiting each other. They're getting closer to each other. Eventually, they will merge, but as they get closer to each other, they spin faster and faster, and eventually they merge. And as they merge, they have spin. So it's not surprising that black holes have a fair degree of spin. Now, the very large black holes, which are spinning, can emit gas, hydrogen gas. I know it's not normally thought that anything can leave a black hole, but in fact the conditions can be such that the velocity of the material on the outside of the black hole, if spinning fast enough, will acquire tremendous speeds, approaching that of the speed of light, and the centrifugal forces are immense, and I believe that terminal velocity will be reached and the gas will spew off the black hole. The black hole will also flatten in shape, it will become discus in shape, and round the circumference of it will be this very hot gas emitted from the black hole. It would look somewhat like a Catherine wheel. This gas will accumulate and mix up with the gas from other black holes, and there will be pockets of dense hydrogen gas. These are basically what you might call stellar nurseries, where the formation of stars will occur. The stars will always be created in the central region of a galaxy. They will then, after they have merged, they will then move away from the centre. Why do they move away? Because there is what I call a galactic wind. There is an enormous amount of hydrogen gas being emitted, and it will flow away from the central regions of the galaxy, and it will apply a force on the stars, nudging them away from the centre. I mean, if you take our sun, we're a long way away from the centre of the Milky Way, but go back 5 billion years or more, it was near the centre of the Milky Way. It's moved all that distance with time, and this is happening to all stars. When they move away, they tend to, for some reason, follow a path, which is the spiral arm, and then after 10, 15 billion years, they will burn out and become a neutron star. The neutron stars many of them will migrate back towards the central region of the galaxy and join all the other black holes which are circulating near the centre. There will also be, from these burnt out stars, heavy elements, rocks, if you like, asteroids. A lot of those will find their way back to the central region of the galaxy, and that material will be used to form the heavier element planets around the stars that form. Also, a lot of the gas, hydrogen gas, radiating from the central region of the galaxies will eventually not form stars, but will eventually leave the confines of the galaxy itself and go into the intergalactic area, the area between galaxies. And as in my previous talks, this gas will contribute towards all the dusk that exists throughout the universe. This gas, by the way, is at a temperature of about +2 degrees above absolute zero, and will radiate infrared with a wavelength of around 2 centimeters. This is observed as the cosmos microwave background radiation. This radiation is nothing to do with a Big Bang echo. It's just the radiation you get from all this dust, and the density of this dust throughout the universe is a sort of a constant. It's the same wherever you go. I mean, when I say, there will be areas of nebulae more denser, but if you take distances over several billions of light years, the mean density is the same all over the universe. And this dust, by the way, is the cause for redshift, which occurs in photons travelling through the universe. The redshift is not due to an expanding universe. So I've basically summed up many things about my hypothesis, and it'll be very interesting in the next few next few months to see the sort of results that the James Webb telescope is going to bring us. Should be very exciting times. There are two main types of galaxies that exist: the spiral galaxy with the spiral arms, and the elliptical galaxy. The elliptical galaxy is just a glow, bright area in the centre and a glow around it. There are no real signs of stars. Now, my theory of a collection of black holes at the centre of a galaxy is such that I can explain the elliptical galaxy. Basically, the gas which is coming off the black holes is not dense enough to perform what's called a stellar nursery, and there is gas coming off and radiating, but no stars are formed. This situation can be continued for many billions of years. So when one of these galaxies are observed, there's just a glow due to the higher energy of the gas, hydrogen gas, radiating from the central region. Now, of course, if the black holes merge together in another way at any point in time, they could start emitting more gas to a point that stellar nurseries are formed. That is, the gas can form a nebula which is dense enough to form stars, and then stars start to be created. They radiate away from the centre, and in effect an elliptical galaxy can convert itself into a spiral galaxy. And conversely, a spiral galaxy, which has had for many billions of years a continuous stream of stars being formed, that formation of the stars could stop. The black holes may realign themselves so that there is not sufficient density of gas to form stars. Then what will happen is the spiral, after 10-15 billion years, the stars in the spiral arms will extinguish, burn out, and after a time you'll have an elliptical galaxy. It could be said that all the stars in the galaxy are really just an incidental event, and the main part of the galaxy is just the black holes in the centre.